AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it.
Imagine, opening your credit card statement at the end of the month.
Oh, that's always fun.
Right. But you look at it and you see a $5,000 charge just because you were asking an AI too many questions.
Yeah, that is a very real, very painful reality right now.
It is. And that's the actual breaking point we're hitting today for heavy users. I mean, the tech giants know it, and as of this week, based on what we're tracking, they are fundamentally redesigning the silicon in our machines.
Oh, absolutely.
Just to ensure that computing power gets cheaper, faster, and crucially, moves off the cloud and directly onto your physical desk.
Right, because it's a complete inversion of how we've handled computing for the last decade. Everyone has just been renting time on these massive centralized server farms, but the energy costs and the latency, the time it takes for a signal to just travel to a server and back, they've hit a wall.
A massive wall.
Yeah. So now we're seeing this kind of dual hardware war. The big players are designing hyper-specific custom chips for their data centers, while, simultaneously pushing enterprise-grade compute power down into consumer desktops.
Right.
The sheer engineering muscle behind this shift is it's staggering.
Okay, I hear the enthusiasm, but we really need to stay grounded here.
Fair enough.
Because whenever hardware companies start an arms race, it's usually the consumer who ends up footing the bill for like a highly experimental overpriced toy.
Well, sometimes, yeah.
So we have to figure out if these new chips actually translate to a cheaper, more useful workflow for the everyday user, or if this is just, a vanity project for tech executives.
Let's break it down.
We're going to map out exactly what is happening under the hood today. And by the way, if you want to understand the actual mechanics behind these shifts instead of just, reading the hype, hit subscribe on the AI Verge on YouTube.
Yes, please do.
It's how you stay ahead of the curve.
Exactly. So let's start with the biggest macro shift in the data center. According to our sources, OpenAI has officially secured working silicon for its first ever custom inference chip.
Right, the Jalapeño.
Yes. Internally, they're calling it the Jalapeño. And what is really blowing engineers' minds right now is the timeline.
Because it was incredibly fast, right?
It's insane. They partnered with Broadcom and went from the initial design phase to a manufacturing-ready chip in just 9 months.
Okay, wait, 9 months?
Yeah, 9 months.
In hardware development. I mean, a 9-month turnaround for custom silicon is basically unheard of. Usually that takes years.
Years. Easily 3 to 4 years minimum.
So 9 months is aggressive, but before we get swept up in the speed of the production, I think we need to clarify what this chip actually does.
Okay, sure.
Because you use the term inference, and if I understand this correctly, there are 2 distinct phases in AI, right?
Right, you've got training and inference.
Yeah. There's training, which is, I guess, like sending the AI to a 10-year, highly intensive culinary school where it learns everything about food.
Oh, I like that, yeah.
And then there's inference, which is just asking that trained chef to cook you a burger on a Tuesday night.
That is a perfect analogy.
Yeah.
Yes, exactly.
Okay, so if the Jalapeño is strictly an inference chip, it doesn't train the models at all.
Not at all.
It just cooks the burgers.
It just cooks the burgers.
So why do they need a completely custom, highly expensive chip just to run a model that has already been trained? I mean, what's the catch?
Well, because right now they are using the exact same massive, power-hungry chips to cook the burger that they used for the culinary school.
Oh, I see.
It is incredibly inefficient. Nvidia's GPUs are phenomenal at training because they can handle these massive parallel mathematical equations.
Right, the really heavy lifting.
Exactly. But when you're just running a prompt, like when you ask a model to just summarize a PDF, you don't need that heavy, generalized architecture.
You just need it done quickly?
Right. You need a streamlined, hyperfast pipeline. Which brings us to the actual engineering specs.
Yeah, let's look at the numbers because the data from the open source InferenceX benchmark shows exactly why they built this thing.
The numbers are wild.
Jalapeño is going head-to-head with Nvidia's flagship Blackwell chips, and it is winning on what seems to be the most important metric in tech right now, which is performance per watt.
Yes, performance per watt is everything.
So the Blackwell draws about 1,200 watts of power.
Huge.
But the Jalapeño runs at just 700 watts.
Right. And it's not just sipping less electricity. That 700-watt threshold, it's returning answers up to 3.6 times faster.
Wow.
And it's doing 1.9 times more total computational work per watt than the Blackwell.
Okay, so it's doing almost double the work with nearly half the power.
Exactly. And to understand why that matters, you really have to look at the physical reality of a data center.
Because it's not just a big empty room.
No, a watt isn't just about the electricity bill, it's about heat. When a chip pulls 1,200 watts, it generates a massive, massive thermal load.
Right, things get literal hot.
Very hot. You have to build complex liquid cooling systems, which, take up physical space, and they require even more power just to pump the water around.
Oh, so you're spending power just to cool down the power you're already spending.
Exactly. So by dropping the power draw down to 700 watts while actually increasing the speed, OpenAI can pack significantly more chips into the exact same physical warehouse without, melting the server racks.
Right, so the infrastructure scales without needing to build a new nuclear reactor next door just to power the thing.
Exactly.
Okay, I get the physical benefit, but there is a detail in the development process of this chip that feels, honestly, a little circular to me.
Oh, you mean the design process?
Yeah. Our sources say they use their own upcoming AI models, specifically Astra and Codex, to help design the physical architecture of the Jalapeño chip.
Yes. And this is arguably the most fascinating mechanical detail of the whole story. It's a closed feedback loop.
How does that actually work, practically?
Well, designing a microchip is essentially a massive game of urban planning, right? You're trying to lay out billions of tiny logical pathways.
Like roads and highways.
Yeah, exactly like roads. And you have to optimize exactly how the electrical signals travel so they don't cause traffic jams or, overheat certain sectors of the city.
Okay.
So OpenAI used their coding models to simulate and route those pathways on the silicon.
Wow.
So you have an AI software model optimizing the physical hardware that will eventually be used to run the next generation of that exact same AI software.
That's just compounding acceleration.
It really is.
It sounds incredibly futuristic, but let me apply the brakes here.
Okay, hit me.
OpenAI isn't putting this chip on Best Buy shelves.
No.
They aren't selling it to other companies. It is strictly for their internal server farms.
Mm.
Furthermore, the production pipeline isn't slated to fully ramp up until 2027.
Which is a long time in tech.
Right. In the AI space, 2027 might as well be the next century. Plus, because this is only an inference chip, they are still completely dependent on Nvidia to buy the GPUs required to actually train their future models.
That is true. They still need Nvidia for the culinary school.
Exactly. So if we can't buy it, and they are still chained to Nvidia for the heavy lifting, why should anyone outside of an OpenAI boardroom actually care about this today? Like, who benefits?
You, the end user, should care.
Yeah.
And it all comes down to the token economics and the latency bottleneck.
Okay, walk me through that.
Well, you mentioned earlier that heavy users are hitting a breaking point with API costs, right?
That huge credit card bill.
Yeah.
Okay.
Every single time you send a prompt or ask an AI agent to read a document, you're charged a fraction of a cent based on the computational power required. The tokens. Right now, running those tokens on NVIDIA hardware is really expensive. But OpenAI's head of hardware explicitly noted that Jalapeño targets low-latency, high-volume applications, and they specifically pointed to an upcoming feature called Codex Ultra-Fast mode.
Meaning the end user gets much faster code generation.
Much faster and much cheaper. I mean, if OpenAI can double their computational output while cutting their electricity and cooling costs in half, those infrastructure savings eventually trickle down to the token pricing.
Assuming they pass those savings on.
Assuming they do, yeah. But it means everyday developers can afford to run more complex multi-step AI agents without just bankrupting themselves on API calls. It turns AI from an expensive, metered utility into something that feels as fluid and costless as doing a Google search.
Okay, I see the economic argument for the cloud getting cheaper. But relying on a massive corporation to pass their savings down to the consumer is, always a gamble. And that reality serves as a pretty perfect bridge to what is happening on the consumer hardware side. Because while OpenAI is trying to make the cloud slightly cheaper to rent, other hardware makers are realizing that users want to bypass the cloud entirely.
Exactly. The ultimate solution to expensive cloud computing is just local computing.
Doing it yourself.
Yeah. We're seeing this massive push to bring these powerful models directly onto the user's physical desk, and Apple just threw down a massive gauntlet with their new M5 and M6 Mac lineups.
Yeah, according to what we're tracking, we are looking at the new Mac Mini featuring the M6 chip, which has a starting price of $899.
Pretty accessible.
Very. And then on the higher end, you have the Mac Studio equipped with the M5 Ultra, which starts at roughly $5,500.
A beast of a machine.
But here's the thing. Apple usually pitches these desktop machines to creative professionals, right? Like film editors rendering 8K video or music producers with 100 audio tracks.
Yeah, the classic Apple demographic.
But the messaging around this launch has completely pivoted away from Hollywood creatives.
It really has. It's a profound shift in their market identity. They are explicitly targeting AI agent developers and power users now.
Why the sudden shift?
Because they watched consumer behavior earlier this year. There were actual physical shortages of the previous generation Mac Mini.
Really? Just sold out everywhere.
Sold out because developers were buying them by the pallet to use as dedicated local AI servers.
Oh, wow.
Yeah. They were running persistent, always-on software agents like OpenClaw that basically act on your behalf 24 hours a day. Apple saw that behavior and just completely retooled the M6 to support it.
Okay, let's unpack the mechanics of that retooling because the spec sheet highlights two major changes. Neural accelerators inside the GPU and something called unified memory.
Yes. Unified memory is huge.
For someone who isn't a hardware engineer, explain why unified memory is the secret weapon for running local AI versus just, the standard RAM you'd find in a regular PC.
Okay, it comes down to how quickly the brain of the computer can access information. Think of a traditional PC like a large commercial kitchen.
Okay, back to the kitchen.
Back to the kitchen. Your main processor, the CPU, is the head chef. Your graphics card, the GPU, is the pastry chef.
All right.
But the ingredients, the memory, are stored in a refrigerator all the way across the room. Every time the chefs need an ingredient, data has to travel back and forth across a motherboard bridge.
Which takes time.
Exactly, it creates a bottleneck. But Apple's unified memory architecture takes all that memory and integrates it directly onto the processor chip itself.
Oh, so it's right there.
Yeah, it's like giving both chefs a massive shared cutting board right in front of them. When you're running a local AI model that requires moving gigabytes of data back and forth instantly, that unified approach prevents the system from lagging or just totally crashing.
Okay, that makes sense. And on top of that shared cutting board, they've added neural accelerators directly into the graphics processing cores for the first time on the Mini, which, according to the benchmarks, delivers 4 times faster AI performance than last year's model.
Which is incredible for an $800 machine.
Right. So Apple is clearly capturing the lower to mid-tier local AI market. But Perplexity, a company primarily known for its AI search engine, they just made a hardware announcement that targets the extreme high end.
Yes, it did.
They are partnering with Nvidia to release something called the portable computer.
Right. Perplexity is basically taking their proprietary search and agent software and boxing it into the Nvidia DGX Spark desktop.
And to call it portable is a bit of a stretch, right?
Yeah, it is a dense, heavy workstation.
Yeah.
But mechanically, it is a monster. It packs 120 gigabytes of that unified memory we just talked about, and it is capable of running up to a petaflop of compute.
Okay, let's ground that term right now, a petaflop.
Okay, a petaflop means a computer can perform 1 quadrillion floating point operations per second.
A quadrillion.
A quadrillion. 10 years ago, you needed a machine the size of a tennis court to achieve a petaflop.
And now it's just sitting on a desk.
Now it sits next to your coffee mug. And the entire point of this machine is to allow you to download massive open source models like Alibaba's Qwen 3.8, the one with 27 billion parameters, and run them entirely locally without ever connecting to the internet.
Okay, I have to jump in here with a reality check.
I knew this was coming.
The price tag on the DGX Spark is $4,699, nearly $5,000.
Yep.
Are we seriously supposed to believe that an everyday consumer, or even like a mid-level professional, is going to drop $5,000 on a bulky desktop machine just to avoid paying a $20 monthly subscription to ChatGPT?
Well, no.
That barrier to entry is absurd.
Yeah.
Releasing a $5,000 box feels like a massive misstep for a company that built its brand on accessible, web-based consumer search. Is this just noise?
For a casual user who just wants, recipe ideas, yes, it is complete overkill. You don't need this.
Right.
But you have to look at the enterprise developers and the data-sensitive industries. Let's go back to those always-on agents I mentioned, like OpenClaw.
Okay.
These are autonomous programs that sit in the background of your computer, constantly reading your emails, organizing your calendar, drafting replies, and sorting your files.
Just doing everything for you.
Exactly. But if you run an agent like that through a cloud provider, it is sending an API request every few seconds, 24 hours a day.
And every request costs a fraction of a cent.
Exactly. So when you do the math on a heavy automated workflow, a power user can easily burn through $5,000 in cloud token fees in just 3 or 4 months.
Oh, wow.
Yeah, so buying the DGX Spark is actually a cost-saving measure for them. It's a one-time capital expenditure that just completely zeroes out your ongoing cloud bills.
Okay, I see. You essentially buy the cow so you stop paying hourly for the milk.
Yeah. Precisely. That's exactly it. And there is an even bigger factor here, which is data privacy.
Right, the enterprise issue.
Yeah. Imagine you're a corporate lawyer or a healthcare researcher or a defense contractor. You want the benefits of an AI agent analyzing your thousands of case files or, patient records.
But you can't just upload that to the cloud.
Exactly. Legally and ethically, you cannot upload those sensitive documents to an OpenAI or Google server. A machine like the DGX Spark allows you to point a hyper-intelligent AI directly at your most sensitive, classified local hard drives, and not a single byte of that data ever leaves the physical room.
Okay, that makes perfect sense. The enterprise data compliance argument is bulletproof. If local hardware can solve the privacy bottleneck while simultaneously killing the recurring cloud subscription model, it is a trend that changes how businesses actually operate.
100%.
But let's take a sharp turn here, because we have been talking entirely about hardware designed to run text and coding models. But according to our sources, there is a new development that is completely abandoning text prediction and is aiming at something far more complex.
Yes. This is one of the most significant architectural pivots we've tracked in a while. A new startup called Accelerated Understanding just stepped into the spotlight.
Right, out of Caltech.
Yeah, it's spearheaded by Anima Anandkumar, who is a prominent professor at Caltech, and Benedict Jenik, a highly regarded AI engineer. And they are not trying to build another chatbot. They are training AI to forecast physical reality.
Okay, to make that concrete, traditional AI, the models we use every day, they're essentially ultra-fast autocomplete engines.
Pretty much.
They ingest billions of pages of text, and when you ask a question, they use statistical probability to guess the most logical next word in a sentence. They don't actually know anything. They are just incredibly good at text pattern recognition.
Yeah.
So how does accelerated understanding break away from that? Like, what's different?
By completely abandoning the architecture that makes chatbots work. Chatbots use something called a transformer architecture, which is brilliant at analyzing sequential data, like words in a paragraph.
Right, one after the other.
Yeah, but Anand Kumar and Jenik are using what they call physics-based neural operators. Instead of tracking words on a page, these operators track physical events through three-dimensional space and time.
Okay, I need an analogy here to visualize this. If a transformer text model is an advanced autocomplete, what is a neural operator? Is it more like, a digital wind tunnel?
That is exactly it. A digital wind tunnel is a perfect way to look at it. A language model predicts that the word rain follows the word heavy, but a neural operator model simulates the actual physics of a rainstorm.
Wait, really?
Yeah, it calculates the atmospheric pressure, the thermal dynamics, the fluid motion of the water droplets, and exactly how gravity affects their trajectory over time.
But the scale of data required to simulate real-world physics must be just astronomical compared to predicting text.
Oh, it is. It's massive.
Right.
In their initial testing phases, their model processed 5 trillion individual data points in a single continuous run.
5 trillion.
5 trillion. To put that into perspective, that is roughly 5 million times the amount of data that a top-tier large language model processes when generating a response.
That is hard to even wrap my head around.
They are tracking the minute interactions of particles and forces on a scale that just breaks traditional compute models.
What fascinates me about this isn't just the math, though. It's the sheer conviction of the founders.
Yeah.
Because the internal filings we're tracking show that Anand Kumar and Jenik were originally part of a massive $12 billion initiative funded by Jeff Bezos known as the Prometheus project.
Yes.
And they walked away from a 35% equity stake in that Bezos-backed venture just so they could build this specific neural operator technology on their own terms. I mean, walking away from that kind of money is crazy.
It is crazy, but walking away from billions in backing is also the ultimate market signal. They fundamentally believe that generalized text-based AI is hitting a plateau, and that physical AI is the actual frontier.
So what are the practical applications for a digital wind tunnel?
The use cases are endless. We're talking about designing entirely new heat-resistant materials for microchips by simulating their molecular stress points without having to build physical prototypes.
Which saves millions of dollars.
Exactly. We're talking about hyper-localized, extreme weather forecasting that can predict the exact path of a tornado hours before it forms.
And it has to be huge for robotics, right? One of the biggest hurdles in robotics, as I understand it, is the sim-to-real gap.
Right, the simulation to reality gap.
Yeah. You can train a robot to walk perfectly in a computer simulation, but the moment you put it on real carpet with real gravity and friction, it just falls over because the simulation wasn't physically accurate enough.
Exactly. The sim-to-real gap exists because our current simulators use these rigid, simplified physics engines. But if accelerated understanding can provide a neural operator that perfectly mirrors real-world physics down to the microscopic level of friction and air resistance,
And what happens?
you can train a robot brain in a virtual environment for 1,000,000 hours, drop that brain into a physical titanium chassis, and it will flawlessly perform the task on the first try. It bridges the gap between software intelligence and physical execution.
Okay, I actually love that. I love that they are ignoring the consumer chatbot noise and focusing strictly on enterprise-grade physical forecasting. That is a massive signal.
It really is.
But I want to pivot from simulating tornadoes to something our listeners can actually touch and use today.
Yes, let's do it.
Let's get into the practical segment. Based on what we're tracking, we have an actionable, highly effective workflow you can test out this weekend using the tools currently sitting on your laptop.
And this is honestly one of the cleanest workflows we've tested recently. We're going to look at how to rapidly build a prototype for a static website, like a personal portfolio, a landing page, or a project gallery.
And doing this without writing a single line of code, right?
Right. No code, and without wrestling with those incredibly frustrating, rigid template builders like Squarespace or Wix.
Ugh, the problem with those template sites is that you always end up fighting the interface.
Always.
You want to move an image 2 pixels to the left, and the entire page layout just collapses on itself.
It's infuriating.
Building a clean, functioning mockup usually takes hours of tweaking menus.
Yeah.
So how does this workflow bypass that? What is the actual setup here?
The setup is incredibly minimal. You just need two things. First, you need the desktop application for Claude. Specifically, you need to use the voice feature on the mobile or desktop app.
Okay.
Second, you need a single local folder on your computer containing the actual photos you want to use and maybe, a couple of screenshots of other websites you like for design inspiration.
All right, so I have my folder of images and I have Claude Voice open. My instinct, if I already have the design in my head, is to immediately open a code editor or a text prompt and just start typing out layout instructions. How does the voice feature short-circuit that process?
It short-circuits the process by acting as your project manager. Step one is entirely conversational. You start the voice chat and simply explain your broad concept out loud.
Just talking to it.
Yeah. You say, I need a minimalist portfolio for my photography, I want a dark theme, and I want an asymmetrical grid. But here is the crucial prompt. You ask Claude to interview you.
Oh, interesting.
Yeah, you tell it to ask you questions one by one to nail down the brand direction, the typography, and the layout structure before any code is ever written.
That is brilliant. You are verbally workshopping the user interface. It forces you to articulate what you want, and the AI helps you find the blind spots in your design before you commit.
Exactly. It's so much better than just guessing. So once you have verbally agreed on the direction and answered its questions, you stop the voice chat. You then immediately type into the text interface. Write out the full step-by-step build plan based on our conversation.
So it writes down what you just talked about.
Right. It acts as a permanent text-based blueprint of the design you just finalized.
Okay, so the blueprint is locked in text form. Now we have to actually generate the site.
Right.
What is the physical workflow to get the images into the code?
This is where you switch entirely to the text interface. You drag and drop your local folder of photos directly into the Claude chat window.
Just drop them right in.
Yep. Then you use a very specific prompt. You tell Claude, build the prototype as a static site using the agreed-upon plan. It will instantly begin generating the HTML and CSS in a preview window right next to the chat.
Okay, let's apply this to a real-world scenario to see how it holds up.
Okay.
Let's say a wildlife photographer just got back from an expedition. They need a highly visual, fast-loading portfolio to showcase their field logs, GPS coordinates, and hero shots. Specifically, images of elephants, a snow leopard, a humpback whale, and a red fox.
Awesome.
So they dump those raw images into Claude, run the prompt, and it generates the layout.
Yeah.
But as the resident skeptic, I have to throw a red flag here. AI coding agents are notoriously terrible at local file pathing.
Yeah, that is a known issue. Explain what you mean by file pathing for those who haven't coded, though.
Sure, when you write code for a website, you have to tell the code exactly where to find the picture on your hard drive. It's like drawing a map to your house.
Right.
But AI models frequently hallucinate those maps. They will write code that looks for the snow leopard image in a folder called downloads image cat that doesn't actually exist on your machine, resulting in a website full of broken image icons.
Exactly.
So how does this workflow solve the broken map problem?
It is a massive point of failure, which is why there is a very specific, non-negotiable pro tip you have to use here. If Claude skips your images or breaks the file paths, you must type this exact phrase: use photos in this artifact.
Use photos in this artifact. What does that actually do under the hood?
It forces the AI to abandon the map entirely and just bring the house with it. Specifically, it forces Claude to convert your dragged and dropped images into base64 data.
Okay, again, translate base64 for the non-developers.
Right, sorry. Base64 is a way of taking a physical image file, like a JPEG, and translating it into a massive, thousands of lines long block of text characters.
So the picture becomes text.
Exactly. When Claude writes the code for your website, instead of saying, go look in this folder for the picture, it embeds that giant block of text directly into the HTML file itself. The browser reads the text and renders the picture.
Oh, wow.
Yeah, because the image is hard-coded into the file, there are no file paths to break. The preview will perfectly display your elephants and snow leopards every single time.
That is incredibly clever for prototyping. But let's talk about the underlying code structure it's building. Because the engineering notes on this workflow mention that Claude heavily relies on a Tailwind CDN to style the website.
Yes, it does.
Tailwind is great, but relying on a CDN, a content delivery network link, means the website is constantly pulling its design rules from an external server on the internet, rather than having the CSS styles baked into the local files.
Yep.
That is fine for a quick visual mock-up on your laptop, but if you launch a production-level high-traffic website using a simple CDN link, your load times will be terrible, and if that external server goes down, your website loses all its styling and looks like a Word document from 1995.
Your skepticism is 100% accurate, and we have to establish firm, practical guardrails here. The exact keyword you used in the prompt, static site, is the safeguard.
How so?
By explicitly telling the AI to build a static site, you are intentionally forcing the agent to keep the underlying code incredibly simple. It prevents Claude from trying to spin up complex backend databases, node modules, or unnecessary server logic. But you are absolutely right about the CDN limitations. This workflow is strictly a visualization tool.
Right. It allows you to see the idea in your head rendered on a screen in 3 minutes rather than 3 hours.
Exactly. You use this to get visual buy-in from a client or to test a layout concept. But before you actually buy a domain name and launch this wildlife portfolio to the public, that generated code needs to be properly compiled, the CSS needs to be localized, and the base64 images should probably be swapped back to optimized JPEGs to save bandwidth. It is a prototype generator, not a final deployment tool.
Which makes it the perfect low-stakes experiment. We want to challenge you to actually try this. Carve out 30 to 40 minutes this weekend. OpenClaw. Use your voice to debate a design idea for a personal landing page. Drop a few photos into the chat and see how close you can get to a pixel-perfect mock-up without typing a single line of HTML yourself. It fundamentally changes how you view website creation.
It really does. And if you are going to take that weekend challenge and build alongside us, please make sure you hit subscribe on the AI Verge so you don't miss next week's workflow teardown. We sift through the thousands of AI tutorials out there to find the very few that actually save you time.
Let's bring it all together with a crisp recap of the signals we separated from the noise today. The defining macro takeaway is that the physical limits of cloud computing are forcing a total architectural redesign. OpenAI's Jalapeño chip is attempting to save the data center by drastically cutting power consumption and increasing inference speed, which should eventually lower your token costs. Meanwhile, Apple and Perplexity are trying to bypass the cloud entirely by putting massive unified memory and local processing power directly on your physical desk.
And the one major conceptual leap to keep your eye on is the pivot toward physical AI. The team at Accelerated Understanding walking away from Jeff Bezos to build neural operators is a massive indicator that the tech world is looking beyond next word text prediction.
Absolutely.
They are building the digital wind tunnels that will eventually solve real-world problems in material science and robotics.
And of course, your weekend action item. Use the Claude voice feature and the Base64 image trick to verbally architect and instantly code a static landing page.
Testing these local workflows is the best way to understand the actual boundaries of what this technology can achieve right now, independent of the marketing hype.
I want to leave you with a thought on this hardware shift we've been discussing. If Apple and Perplexity succeed, and we all end up running incredibly powerful, hyper-optimized AI models entirely on our local machines without relying on the cloud, those models will eventually become perfectly efficient for the hardware they live on.
Yeah.
And if the software doesn't constantly bloat, demanding more power from the cloud, does the hardware upgrade cycle die?
Oh, wow.
I mean, if a $5,000 DGX Spark or an M6 Mac handles every local autonomous agent flawlessly, you might never need to buy another computer for a decade. The tech giants are racing to build the ultimate local machine, but in doing so, they might accidentally kill the very subscription and hardware upgrade cycles their empires are built on. Something to chew on.